Hello, everyone, and welcome to this session where we're going to talk about how you can build models using AutoML. My name is Zach Akil, and we're going to be joined later on by my colleague, Yuhan. I'm going to first show you how we can build models using just the UI, and then Yuhan is going to show you the same steps, but using the SDK. Let's look at the data set that we're going to use to build our models. This is an open source data set that we got on Kaggle, and it's an X-rays data set. And more specifically, it's an image classification data set. So it's going to be trying to predict if an image contains pneumonia or not pneumonia. Let's jump right in to see how to build your models with the UI. All right, so we're here in the dashboard. We're going to get started by first creating our data set. So we will click Create Dataset. And here we get to choose what type of data set we want to create. So there's a few different options in terms of if we want image, tabular, text, or video. And in our instance, we are going to do an image data set. And more specifically, we're going to be doing a single label classification because there's only going to be one label we're predicting, which is whether the X-rays contain pneumonia or not. So we're going to click single label classification, that's selected. And we should also at this point name our data set. So we'll just call this one X-ray. And hopefully we hit create, and that will create our sort of blank data set. And it's then going to give us the options to actually upload data into the data set. And the way we're going to do that is we're going to have the data already in Google Storage. So we're going to not import from our computer, not import there. No, we're going to import files from cloud storage. Yeah, we'll select that. And here is where we don't specify the files themselves. We actually want to specify an import file location. What that is going to be a specific file that describes where all of our different images are, along with, if you have them, the labels for each image. So there's actually a doc that explains this here. So we can see documentation for the file specific. So in this instance, it's going to be a CSV file that we're going to use. And the structure has to be, I think this is the simplest structure we can use, which is just the location of the file in Google Storage. And then we also have the labels. So we're going to use the location of the file separated by a comma, followed by the label for that specific image. And then have all of our images listed like this. So let's look at Google Storage to actually see our data set. So here it is. If we look inside this folder, you can see we have two more folders, one containing all the images of just normal X-rays, and we can look at these. So we'll look at one of these, and there's one of the images, and then we'll go back, and you've got the same for pneumonia. Now all these images are just stored in this folder structure. So what I'm going to do, I'm going to run a bit of code that's going to use this folder structure to generate our import file. Okay, so I've got the Cloud Shell editor open, and I've got a very small script that's going to look at a specific folder in Google Storage and generate for me my import file based on the folder structure. So what we'll do is we will run that script. Okay, let's have a look at the generated file. All right, so you can see we've got a location of an image separated by a comma and then a label name. So if we scroll down this, we should be able to see, yep, there's some pneumonia labeled images. Okay, so that all looks good, but that's just in the Cloud Shell. Let me just copy that over to Google Storage. So we should have one, yes, here we go. So we will use the Google Storage utility library to copy that labels file into our dataset folder. All right, now if we refresh here, there we go. There's our labels file right there. All right, we'll jump back over to the UI and specify that file. There it is. And we'll try to import this. Okay, so the importing process can take some time, but you don't need to stay on this page. You can close this down and you'll receive an email when the import is finished. After the data has been imported, we can see the data set in the UI. And it even gives us an option to go in and change the labels. Maybe if some of the images have the wrong labels, you can change them all within the UI. But the next thing we want to do is to train a model on this data set. So we'll click Train New Model. And here we can specify if it's going to be maybe an edge model, but for ours, we'll just do one that's going to be hosted in the cloud. So we'll leave that. We give them all a name. It generates one for us, so that'll be fine. And then finally, how many hours we want it to train for. And what's great about this is that if early stopping is enabled, which it is by default, if it plateaus in training performance, maybe in the first couple of hours, but you set it to train for maybe 20 hours, it will stop and it won't charge you for all the extra hours that you said it could train for. So we'll give this a budget of, let's say, 20 hours and start training. And there we go. It's going to go off and do all the training in the cloud, and it will email us after the train is finished. All right, so after our model has finished training, we can click on it and see its performance. So here are some of the metrics we can see, like precision and recall, and we even have a confusion matrix to show the percentage rate of misclassifications. And we can get a more granular view of misclassifications by clicking on one of the classes here. We can see examples of false negatives and false positives. And this is useful for when you want to go back and tweak the data set. Maybe you want to add more examples that are similar to the ones you're seeing here. But after we've got that, all that's left is to productionize our model. So we'll go over to the Deploy and Test tab, and we'll create here an endpoint. We'll give this a name, X-ray. Traffic's about 100%, number of compute nodes, give it 1 compute node to begin with, and that's it. We hit done there. Everything looks good here, and we'll hit deploy. Finally, once the endpoint is deployed, we can test it with some data. So I'll go here and I'll upload image to see what it comes back with. So there we go. This one predicts this image to be normal, and let's test it with another image. And this one predicts high likelihood of pneumonia. And this is just a way for us to test the model. There's ways to actually send API requests, maybe if you've got a service or an app that wants to call this model. But yeah, that's the process of building and deploying a model with AutoML just using the UI. And I'll hand it over to Johan now to show you how to do the same thing with the SDK. Thank you.
My name is Johan. Zach just showed us how to go through the steps of creating a data set, training a model, to getting predictions from a deployed model in the UI. But there are times you might want to automate or reiterate some of these steps. Then it can be more convenient to interact with services programmatically using the SDK. Let's see how to do that.
Okay, we're going to start by installing the client library. And now I'm working inside of a newly created virtual environment, so there's nothing in it, so we'll install it. And this is the SDK that we're going to use today. At the same time, let's also install IPython so that we can do some exploration work while waiting for things. Okay, let's also make sure that we have access to the project we want to use to run the APIs. So previously, I had already created a service account in the project I want to use and downloaded a copy of the key. So here is the key.json file, and I'm going to export that to the environment variable of Google application credentials. That way, when we start using the library, you will be able to be authenticated. Now let's look at the code. Here we're going to try to run the step for create and import dataset. We import library and initialize it with a project number, or you could use project name instead if you prefer, and give a location. And we're going to create an image dataset with a human readable display name and a source index file. We'll look into that a little bit. And some metadata that describes the dataset is going to be image dataset with the purpose of single label classification. And we'll set synchron to be true. That way we can just wait for it. And at the end of execution, we're going to get back the dataset display name, should be the one we set, and a full resource name, which we'll need for the next steps. Okay, let's go ahead and execute this. And then you see the API has been called and it's in the middle of running operation, and you see logs being printed. And while waiting for that, since it takes maybe a few minutes, let's take a look at index.json file. The format of the index.json file is fairly straightforward. It's one JSON object per line, and each JSON object here has two keys. One is image GCS URI that points to the full name of each file. And the other one is classification annotation key that points to another object that describes the name of the classification label. After a few minutes, the dataset has been created and data imported to it. So now we can move on to the next step of training. Here again, I'm importing the library and initializing it. If you run multiple steps of the workflow in a single script or maybe in a notebook, you wouldn't have to do this every time. We'll create a job instance for AutoML image training job with a human readable job name. Calling job.run will result in a model eventually that will be given the display name that we set here. We're setting the maximum node hours to be 8. And we're going to set disable early stopping to be false, which enables early stopping, making sure that whenever the service decides that additional training will not improve the performance much, it's going to stop. That will save us time and money. And set sync to be true, so we can continue monitoring the progress with the logs that are being printed out. What's missing here, though, is that we need to find out the name of the image dataset that we just created, so we can pass into it. So let's do that. So passing here to an IPython session, I'm going to paste these 2 lines of code here so I can access the same project that we just created the data set in. And let's list all the image data set. And there are several. So I would like to find out exactly the one that we just created, and we can do that with filtering. Before, when we created the data set, we set a particular display name. Okay, we can filter with that. So display name was demo-data, and listing with this filter returns only one data set, so we know that's the one we just created. And you can already see the full resource name, which contains the dataset's name that we need. Or we can also get that particular data set and call its name attribute. Then we can get the name of the data set. Copy this over into the training script here. Now this training script is ready to go to trigger training job for the data set we just created. So let's go ahead and run that. Now you can see the API is being called and the training job is running. We'll continue to see the pipeline state being updated. The log will continue to print until the whole job is finished.
You might have noticed that Zach used the CSV file for the import data step, and I used the JSON-L file. In practice, you can use either format from the UI or the SDK. Next, we will deploy the model and get predictions using the SDK.
It took a little over 20 minutes to finish training the model with our dataset. And now that we have the model trained, let's get the model name so we can continue the next step of getting prediction from it. To get the prediction, we have to deploy the model first. And for that, we need to know the name of it. So again, here in the IPython session, I have initialized in my project and search for the model with the exact display name that we had set before when we started training. Okay, I'm going to paste the model name into the code here, and let's go through that. We would retrieve the model that we just trained and call its deploy method to create an endpoint. And in here, there's a traffic percentage argument that you can set because this is going to be a new endpoint with no other model in it. We'll set the percentage to be 100. And we would, right after getting an endpoint, we would like to call it and find out if it can return responses to us. So we will load a local image file from the same data set, in fact, and space 64 encode it, put in the dictionary with the key content, and that's a single instance. Then we put that into instance. For online prediction, you can only put one instance for every call, and we will expect to get a prediction printed out at the end. So let's run it. Deploying model itself could take a few minutes. Now the prediction code has succeeded and returned a prediction object over here, and it shows the display names of the classification labels and the respective confidence scores for the images sent. Sometimes you want to run prediction on a model for a large batch of data as opposed to one at a time. In that case, you should use a batch prediction job. And the way to do that is, again, we have the model that we just trained with our own data, and I need to specify the source, which will be a list of images, and we'll see the format in a second, and a target destination so that the service knows where to put the output. And calling the APIs through the SDK is about the same as before. I need to give a human readable job display name, provide source, target. Again, I'm going to set sync to be true so we can wait for it and watch the log play out. Let's run it. And again, here you can see that log will continue updating you on the progress of the job. And when the job completes, we'll be able to read the output data from the GCS bucket. While waiting for the batch prediction job to complete, let's take a look at the batch prediction input.jsonl file. Its format is very simple. It's again one JSON object per line. In this case, the key is content, and for the value, we just need to put in the full path of the image files that we want the model to predict on. Now the batch prediction job is completed. We would like to look at its output. And first thing to do is to grab the destination prefix that we set when we call the API for it. And we're going to see what files the service has added to that path for us. For that, I'm going to use gsutil. And we see that the service has added another directory in it for us, and it's timestamped, indicating when the batch prediction job has completed. So let's look what's in there. And so there's only a single JSON-L file, likely because we sending only a batch of 2 images. If you have a large batch of data, that could result in a split of many JSON-L files. And we can look at its content as well. And you can see this is really just another JSON-L file with 1 line per JSON object. And each JSON object in there is precisely in the same format as the prediction object that we had seen before from online prediction. If you want to retrieve the batch prediction output programmatically, you can also use the cloud storage client library.
Today, we have seen how to carry out the same workflow with the UI and with the SDK. Actually, they also work really well together. For example, you might use the SDK to trigger several training jobs or batch prediction jobs at once. Then you can easily monitor their progress in the UI. Thank you for joining us. Make sure to check out the documentation site for more information.